Hi, myself Rahul, and I'm here to give you a better idea on the topic buoyancy. Have you ever tried to lift a stone from the river, or have you ever tried to pull water from the well? There is something interesting happening in both the cases. That is, when you're taking or lifting a stone from the river, you might have felt that the stone is lighter when it is inside the river, and when you take it out, it feels much more heavier. The same thing happens while lifting water from the well. So when it is inside the water, it feels lighter, and when it moves out, it feels heavier. The same thing can be experienced while you are bathing as well. When you put the mug inside the water, it feels lighter, and when you take it out, it feels much more heavier. So what is exactly happening? Why does these objects feel lighter when it is inside the water? And why does it feel heavier when it moves out? What is that? What is that phenomenon which reduces the weight inside the water? So we'll see what it is. So it is completely related to this term, which is buoyancy. To understand this concept, let us consider a ball. Say this yellow ball. Now, if suppose I am dropping this ball from this height, you can see this one will move downwards. It is moving downwards because the force of gravity or the gravitational force is acting in downward direction. At the same time, if suppose I am putting this ball inside this transparent bowl, in this case you can see this one floats rather than getting sink or moving to the bottom of this bowl, it actually floats on the water. Right. Now, if suppose I am applying some force on this one, as you can see, if I am applying a force, something like this, and then if suppose I am leaving this one, if I am leaving this bowl, it will come back to the original position, or it will again start floating at the top. So from this experiment, it is very clear that whenever I am giving a force inside, and then whenever I am leaving this, whenever I am leaving my hand from this one, this will come back to the original position. Some pushing force is acting on this one. Okay, on the board, some force, some liquid is exerting some force on this board. So this upward thrust force that is being exerted to this board by the liquid, which is actually water, is actually called a buoyant force. And the property by which the liquid exerts this upward force is called buoyancy. So what exactly causes this upward thrust force or the buoyant force? So to answer this, let us consider this example. As you can see, there is a ball inside this liquid, okay, which is water, and it is immersed in this liquid, and this is the level of the water. Okay, so it is up to this level. Fine. Now, as you all know, the pressure of the water will increase as we go down. Okay, the pressure increases as we go down inside the water. Now the arrows here actually represents the magnitude of the pressure. Okay, so here the pressure is comparatively lower, let this be some P1. Okay, and at the bottom space I have some larger arrows which represents that the pressure at this bottom side is very much higher. At the same time, these two arrows are same, these two arrows are same, and these two arrows are same, because that is along the same horizontal layer. Okay, therefore along the horizontal layer, this two pressures, for example, let it be some P2, which is this is also P2, some P3 means this is also P3, some P4, which this is also P4. Okay, all the magnitude of P2, P3 and P4 are equal and opposite direction. And as we all know, since the vectors with same magnitude and when it is acting in same opposite direction, it cancels out. Okay, so you won't witness any axial, any horizontal movement of the ball when it is immersed. Now here, as you can see, the pressure at the top side, okay, it is comparatively lower, and at the bottom side, let's say some P5 pressure is acting, and as you all know, as it goes, as it increases as we move down, P5 will be very much larger than the pressure P1, and because of this, there is a gradient in this pressure, and this gradient in this pressure will result in an upward force, and this upward force is called the buoyant force. So this is actually responsible for the upward force. Now, what are the factors on which buoyancy or the buoyant force depends? So there are basically two factors on which it depends, and we'll see that in detail. So we have seen how buoyant force is getting originated inside a fluid. Now what are the main factors affecting this buoyant force? So there are basically two factors which affect the buoyant force. The first one is the density of the liquid. Is the density of the liquid or the fluid that is being used. Now to explain this one, let me use the same bowl which we have used earlier. So this is the same bowl. Now there is water inside. Also water is our fluid, and let me insert this pen, okay, which is made up of plastic. Now you can see this is actually floating in the water, right? At the same time, if I use a metal piece, okay, which is made up of a stainless steel material. Now if I insert this one, it is having a weight some even less than this pen. So if I insert this one, you can see this is actually moving down, and that is it is actually getting immersed in this liquid. So why this is happening? Because the density of this material, which is plastic, the density of the plastic material is very much less compared to the density of water, therefore it floats. At the same time, the density of this material, which is your stainless steel, is very much higher than the fluid, which is water, therefore it moves down. So as the density of the liquid increases, the buoyant force also increases. So even water can be made more dense if you add salt to this water. This is the reason why people feel very easy to swim in sea, while it is very difficult to swim in normal fresh water, because sea water will give a more upward force or more buoyant force, which will keep them floating. And there is one more sea which is called the Dead Sea. In Dead Sea, people can float. Normal people can go and they will not get submerged. They will always float in the sea, and that is because the salt content in the Dead Sea is very much higher, so that the density of the sea water or the Dead Sea is very much higher than the density of the human body, so we can float. The second important parameter is actually the volume that is immersed volume of the material. As you can see, this is the immersed volume of this bottle. So let us consider same bottle, two bottles with the same dimensions and all. And if you keep one in the upright position and the one in this position, which one you will have to apply more force so that it reaches the bottom? Just try to picturize in your mind. So which case you will have to apply more force? Yes, it is obviously this one. In this one you will have to apply a higher force to reach this one to the bottom, because more volume of this one is in contact with the surface. So for the more the volume, so the second important parameter is volume of the submerged part. Okay, so volume of the submerged part. So higher the volume of the submerged part, more is the buoyant force. And one more thing that should be kept in mind is that it depends only on the volume of the submerged part and not on the nature of the material. For example, if suppose we consider two different materials, okay, if suppose a body is two different bodies are used. For example, a copper bowl. Let us consider a copper bowl. So let this be a copper bowl and a brass bowl. So let this be a brass bowl. A copper bowl and a brass bowl. Both these material experience the same buoyant force due to the immersed volume. So it is actually irrespective of the. So if both the materials are having same dimensions, then both will experience the same buoyant force irrespective of the nature of the material. Okay, so these are the two important factors concerned with affecting the buoyancy of the buoyant force of a material. So this completes the topic for today. So to get a better understanding of the topic, you are supposed to learn more You are supposed to learn about Archimedes principle as well. So applying that to buoyant force and considering that will give a better idea of the concept. So which we'll try to see in the next video lecture. Thank you very much.